Hello, everybody. My name is Fanis Prodromou. I'm a Google developer expert for Angular. I'm a senior Angular developer at the company ASI. I'm a co-organizer of the Angular Athens meetup, and I'm an Angular content creator. And bottom right corner, you can see my contact details. You can connect with me. Please do so. Why we are here? Well, here today we will talk about how to build a planning poker game with Supabase. And I know that you might be thinking, what is Supabase? And this is what I plan to do. I plan to dive a bit deeper into some Supabase features and understand what they are and how to use that into a real-life application. And of course, we need to have an application. That's why I created the planning poker game, where I will show you how to start coding. Well, in Agile Scrum, there is a meeting ceremony where the developers sit at a round table, they hold some planning poker cards with numbers in the Fibonacci sequence, and they have to estimate the complexity of a user story. And this is, in a nutshell, the flow in a real-life scenario. But how about when we are working from home? So for this one, we need to have an application. So let's create the app. And allow me to say here that I'm not going to solve a problem that exists out there. There are many planning poker games online and free out there, but I like the idea to create just for this presentation a planning poker game and present it to you. So to start, of course, what do we have to do? Engineer planning poker game so that we have our Angular application ready. And the next thing is that we need only one dependency. And this dependency is to install at Supabase/Supabase-JS, the only dependency that we need to have from Supabase. Before we start, I would like to explain to you in a 1,000-feet view what is an end-to-end flow of a user who interacts with an Angular application. Well, we have the user, and the user interacts with an Angular application. The Angular application now requires to have some data. We need some data to apply some business logic, some presentation logic. We need to have our bindings and stuff like that. So how can we get the data? We need to have an API. From the API side now, we need again to have some resource of data. How can we get the data? There are plenty of different sources for this one. We can get from cache, from file system, from whatever, or even from a database, and this is what we're doing here today. So this is, like I said previously, in a nutshell, an end-to-end flow of a user who interacts with an Angular application. But is it only one user? Well, no, we have multiple users. And since we have multiple users, we need to have also an authentication system to know who the user is. And there are some applications that require also to have a real-time communication using WebSockets. And especially for planning poker game, I'm using the real-time communication. So this is a map, let's say. But here today, we talk about Supabase. What can we get from Supabase? We can get the authentication. We can get the API. We can get the real-time, and we can get the database. So it seems that we can get everything from Supabase. But what is Supabase? Well, Supabase is a backend as a service. For those of you who don't know what backend as a service is, it's a solution where it allows developers to focus on the front-end development by leveraging a backend without maintaining it. This means that this map, eventually what will happen is that it will become just one layer, or to state it even better, this will become just one dependency in our Angular application with multiple layers into Supabase, but we don't care about that. I read a comment on Reddit from a Supabase developer who was saying that Supabase is a database, and actually this is how it started. It started as an open source database infrastructure built in on PostgreSQL. Then they started adding more features and more features, and they became to be a backend as a service, which is the open source alternative to Firebase. And it is cited to be 300 times faster compared to Firebase in simple operations. So we're talking about a service. And since this is a service, we need somewhere to host it. We can host it in a cloud platform. We can host it in your own cloud, or you can even run it locally on your machine. These 3 bullet points are very important, and the reason is that there is no vendor lock-in. As soon as you have your infrastructure, you can do whatever you like with your infrastructure. Supabase has plenty of features, but today's talk we will talk about 4 of them: the authentication, database, REST API, and real-time. And let's start with the authentication. In Supabase, we have a built-in authentication system. Built-in authentication system where we can sign in a user using user credentials. We can sign in through one-time password. We can sign in through single sign-on, and we can even sign in through OAuth. Let's see some code examples to understand how to use that. So what we're seeing here is that we have the Supabase. If you remember previously, we installed just one dependency. So this is the instance actually of that dependency. So we have supabase.auth sign in with password, and we're providing the email and the password. And I really like this kind of pattern. For every call, we have the data and we have the error. So we can apply the error handling or capture the data. And this is the method that I also use into the planning poker game. And there is one more to sign up a user where we exactly provide the email and the password. There is also the option to sign in through one-time password using an email. And the method is supabase.auth sign in with OTP, one-time password, where we're providing the email. And the idea is that we are receiving an email, we are clicking the link, we are auto-redirecting, and we are signed in. If you don't like the idea of email, there is also the option of SMS. We have to provide the phone, and the method is the exact same thing. Sign in with OTP, we're providing the phone, and behind the scenes there are some providers that are doing that. One of them that I remember is Twilio, that supports to send all of this kind of SMS. And we can even have the option to sign in through OAuth. And the call is, again, the same thing, supabase.auth sign in with OAuth, and we'll have to provide the provider. And here we'll have GitHub. And you might be wondering, do we have other providers? And it seems that Supabase supports almost all the social providers. And you know what? That's it in terms of authentication. What I would like to highlight here is that I know that authentication is a hot potato, and we need to pay serious attention into the authentication. But in Supabase, we do not have to care about the refresh of the token. We do not have to care about the token expiration, claim validation, nor signature verification. All of these things are happened and handled directly by Supabase. So in our Angular application, all we have to do is just use these kind of methods, minor tweaks, and we are done. So let's now assume that we have finished with the authentication part, and you remember what we're building. We're building a planning poker game. And what do we need for the application? We need to have a board. If you remember, in real life scenario, what we have is a round table, and the developers sit at that round table and have the planning poker cards. So that table is the board. So we have to create the board, we have get the board details, and then we have to update the estimation, where the cards has the Fibonacci cards, the developers have the Fibonacci cards. So 3 different things: create a board, get the board details, and update the estimation. How can we get them? Well, we need to dive a bit deeper into other features, other Supabase features. And let's talk about database. Well, Supabase is a vanilla PostgreSQL database, which is the choice for transactional workloads. And I think it's one of the most scalable databases. And you can query your data using SQL, and they even have a built-in authentication system directly into the database by leveraging the row-level security. This is not a buzzword. This is a very nice feature, and we will see a bit more details later on. And they even have a real-time enabled. So this one, I really like it. And the reason is that the real-time enabled means that whatever changes we do into the database level, at that point of time, a message is propagated to the WebSocket listeners. So we have the database, and we have the Angular application that receives this kind of message. And I know that all of these kind of things sound a bit too much for you and overwhelmed. And you might be thinking, you know what, I'm not a database expert. The good news is that, of course, there is an SQL editor. You can go there and type everything manually if you would like. This is not my type. And I would prefer to use their awesome UI. And I will give you an example of how to create a table. So this is how the UI looks like to create a table. And for this example, I'm creating the table with name users. We can provide a description. we simply have here just a checkbox to enable the row-level security. We will discuss a bit later about that. And then we have to provide some database columns. Let's start with the ID, which is an integer, and this is a primary one. Then I would like to have a created that. This is timestamp. I want to have a default value of now, name, type text, age, type numeric. And if I want to add more columns, I have just to click this button. Add more columns, save, and we're done. We have our database table there. And now we have the database, we have the Angular application, and we need somehow to bridge this distance. How can we bridge that? Of course, we need to have a REST API. So currently we said that into this schema, we have for the database, we have PostgreSQL, but how about API? Well, for API, what Supabase is doing is that is using Postgres, which is a standalone web server that turns your PostgreSQL database directly into a RESTful API. So whatever constraints we might have into the database level, these kinds of constraints are getting reflected to the API. And we can achieve different architectures of this API. I mean, we can go with a two-tier architecture, which means that we have our Angular application, and the Angular application communicates directly with this auto-generated API. And the other option is to use three-tier architecture, which means that we have Angular application, and in between we have our own API server, and that API server uses the Postgres API. So from my side, for the planning poker game, I'm using the two-tier architecture. Let's forget for a while anything about Supabase, and let's focus only into the RESTful API and the principles that we have. And let's get as an example the user's entity. So let's assume that we have the user's entity and we would like to create an endpoint. How can we do that? What are we going to create? First, we need to have a get verb, and the get verb for users endpoint will return a list of users. How about if I want to get a specific user? Again, the same endpoint with one path parameter, the ID. If I want to create, I will use the post verb. If I want to update, I will use the put verb with the ID. If I want to delete something from the database, I will use the delete verb. And if I want to partially update, I will use the patch. So this is what is happening into RESTful API. Let's see now what is happening into the Supabase. Supabase has an auto-generated RESTful API. And if you remember previously, we said that the database schema that we have is auto-generated into an API. So for the user's database table, we have the user's endpoint. For the products database table, we have the products endpoint. And for the contracts database table, we have the contracts endpoint. So let's now see the following. Into this slide, what I'm doing is that I'm splitting into two parts. On the left side, we will have the RESTful principle, the thing that we discussed previously. And on the right side, we will see what is happening in Supabase. Okay, so let's see a comparison. In RESTful, if we want to get a list of users, what we're doing, we have a get verb, users, and this is it. And what we have from Supabase, the same thing. Nice. How about now, if I want to get a specific user? Using the RESTful principle, the thing that we discussed previously, we're providing a path parameter, the ID. But how about in Supabase? In Supabase, we have a query parameter, and we'll see more details later. If I want to create a user, we have the same thing. And if I want to delete a user, we have, again, a query parameter. So let's dive a bit deeper to understand what is happening with this query parameter. What we have here is user underscore ID, and this is the column name, is the database column name. And this is the operator, equals operator, and there are plenty of operators out there where we can use equals, not equals, and many more. And .1 is the value. So what we're doing is that we are filtering directly from the API. And before we go to the next slide, let me tell you that this is, according to REST principle, this is fine. This is accurate. So do you already see how powerful this is? Let me try to convince you. Again, let's forget anything about Supabase. And let's imagine that we have an imaginary application and this application is about contracts, a contracting system. And we'll have this kind of interface. Don't try to read all of these kind of things. They are auto-generated by Gemini. What I would like to highlight is that we have a very huge payload, even 3 times this size. It's a very big one, where we'll have some more interfaces, which means that we'll also have some more joint tables, and so on and so forth. And we need now to create a REST for this one. What we will create a contract endpoint, get verb for the contracts, get verb for a specific contract, if post verb if we want to create, and delete if we want to remove. What I would like to highlight here is that it's a contracting system, and if we get a lot of contracts, of course we will have a performance issue. But even if we get only one, the performance, it will be okay, but it won't be that fast because it has a lot of things happening there. We have the joint tables that requires into the database, requires some resources. We have the API, perhaps we're using an ORM or something like that. In any case, we need to have some data manipulation, and then we have all of this information traveling into the wire, and then we'll have, of course, the actual UI, the Angular application, which again requires some resources to handle of this huge payload. And now, into the same imaginary contracting system, we are developing another feature, and that feature requires to be a bit faster. So what can we do? So what we can do using a REST principle is to create, we will show you later, but what I would like to highlight here is that into that feature, imaginary feature, we don't want to have the joint tables. So we don't want to have the payment details, the compliance, the reviews, and all of these things. How can we solve that? Well, we'll go to the API developer and ask the developer to create a slim sub resource. So we'll have the get contract /slim, and if we want to get a specific contract, we will have the same sub resource. And this works just fine. And we'll have a slim payload. How about now? If we want to have a feature that works very fast, and the only thing that we want to have is contract type, start date, end date, and contractor name. How can we achieve that? Let me ask you. Will you go to the API developer and ask for a sub-resource? Well, we don't do that. We know that even if this has, the slim one has a slight performance implication, we will use this one. But how about if we have a tailor-made query? And this is where we can use Supabase. Tailor-made query directly from the UI, directly from the Angular application. And when I mean tailor-made query, what I'm saying is that we have the contracts, I want to select the contract type, the start date, end date, and contractor name. I know that this is a bit hard to read, but this is what we have to use as Angular developers. We're using the Supabase, the instance that we installed previously. We are defining here the database table, and then we are selecting the columns. Contract type, start date, end date, and contractor name. And that's it. And how about, it's very common to have a pagination, right? How about if I want to have a pagination? And again, this is something that we have to do from the UI. The only thing that we have to do is to chain a different method, and the method is range from 10 to 15. And that's it. We will have a paginated data. And it's very common, other than pagination, also to have a sorting. So how can we achieve the sorting? Same thing. Again, what we have to do is to chain another method, and the method is order. I would like to order by start date ascending false. I feel up to this point that you have a question, and the question might be, are we querying the data from the UI? Well, no, we're not querying the data from the UI. We are initiating a query from the UI. Is it secure? Let me tell you the following. What is happening behind the scenes is that there is an HTTP interceptor, and this HTTP interceptor, whenever we initiate a new query, we send two different things. Sorry about that. We send two different things. The first one is the API key, which is the actual API key that we have to use, and this is part of our environment.ts file. And the other one is the authorization, which is the user authorization token, and this is a JSON Web Token. Okay, so let's now try to decode this JSON Web Token and see more details. Let's focus only into this one, which is a UUID, and this is actually the user ID, and also into this property role, which is authenticated. So we have the user ID and we have the role of that user. Now, let's talk about row-level security. Row-level security is a feature that allows you to implement authorization rules directly into the database. This means that you can control which users can access and modify specific rows of data based on the role that we saw previously and the user ID. In this database table, what we have is the light blue user that created this row. We have the green user that created this row, and we have the blue user that created this row. And we have enabled the row level security. And now we have the light blue user that tries to delete this row. But this is not a row that the light blue user owns, right? And this operation will fail. Will fail simply because we had a specific configuration. And we can even configure that to non-authorized users, not authenticated users, to select the data. So I know that this is a bit too much about the theory. Let's see some code. If you remember, what we're doing is that we would like to create a board, get the board details, and estimate. So how can we do that from the Angular application? From this one, I would like to highlight into two things. So let's start from top to bottom. I created the method createBoard where we have two arguments, board name and user ID. We have Supabase from, and here what we have to select is the database table. And I would like to highlight, this is the number one thing, that we have an IntelliSense. Board members, boards, and profiles. These are the database tables that I created into my Supabase dashboard. And then the other one is that if I want to create something, I have to use just the insert method. I'm inserting, I'm providing the name and the created by, and no more than that. And this is how we are creating a board. And now let's see what is happening here. This is how to get the details. And the method that I created is getBoardById. I'm providing here the ID, and into the from we have to select the database table, boards. And from the boards database table, I would like to select ID, name, created at, created by, and is completed. Okay, these properties are directly from the boards, but boards has also a one-to-many relationship with board members. And we can even select from board members specific properties, ID, created at, value, board ID, and user ID. And the board members has another one-to-many relationship with profiles. And from the profiles, I want to use only username. What I would like to highlight here is that we have even this option. We have the option to create a tailor-made query to get what we need. If you don't like this idea, you can always go with the star sign, star symbol, and use and select all the columns from the database table. This kind of query will result into this response, where we have the properties from boards, board members, and here we have the profiles. And how about now the third one, the third feature, to estimate? If I want to estimate, I created simply just this method with two arguments, sprint value ID and the estimation. Perhaps I have to change this name. I will do that later. And then I have the Supabase from, I'm selecting again here the database table, and I'm updating. That's why I'm using just the .update method here, and I'm providing the value, what I want to update. And of course, here we have the equal operator where we're providing the filtering, what exactly I would like to update. And this is about the API. So this will be my last thing to talk a bit about the real time and a few more slides. So if you remember previously, we created a table and the name was users. We enabled the row level security. And now let's create also and enable the real time. You can do that when you create a table or when you edit a table. And let's see some details into this one. What is happening with this kind of code is that we are creating a WebSocket listener. And we have here the on Postgres changes. We are subscribing to that specific event from Supabase. And we can even narrow it down, providing more details. I would like to listen on every change, or I would like to listen whenever something is using the insert or update or delete. And I can even narrow it down even more by selecting the table and by providing also a filter. I would like my column name to equals to some value. As soon as all of these criteria are met, then we'll have the callback function, we'll have the data, and we can do whatever we like with our data. And demo time. And this will be something like 2-3 minutes. And what I have here is the following. I have two different browsers. On the left side, I have the user Fanis, and on the right side, I have the user Tanya. Two different users, two different browsers. If I go to boards, we can see that we do not have any boards here. Let me zoom in a bit here and here. And again, if I go here to the boards, we can see that we do not have any boards. Okay, so let's go back to the dashboard, and the user Fanis decides to create a new board, and I will name that Sprint 1. So let's create the board, and this is the board details. From the board details, what we can do is estimate the complexity using Fibonacci sequence, 1, 2, 3, 5, up to 15. At least this is what I have so far. Let's now go on the other browser, on the user Tanya, and I would like now to have here the boards. We do not see any board. So let's go back here, and we'll have this kind of symbol. At the time that I'm clicking that, I have just copied a link. I will paste it here. And please pay attention here. When I click enter, we expect to see that user directly into the board. And this is happening by using the real-time communication by Supabase. The right side, the user Tanya decides that this is an 8, and we can see the value here. And we can see that here we have some smiling faces, which means that that user did vote, but we cannot see. We cannot see that yet. We have to reveal the cards first. So let's do the same thing from this user. And this user thinks that this is a bit easier, and I think this is a 3. And again, we'll have the value here, and we'll have the smiling faces. And now it's time to reveal the cards. At the time that we are revealing the cards, we expect both the smiling faces to reveal the figures. So here I have 8, and here I have 3. If you remember previously, what we said is that these kind of changes are happening and triggered directly from the database. This is my database. Let me maximize that a bit. So this is the Supabase dashboard, and what we can see is that we have here 3 different entries, one with figure 3 and the other one with 8. So what will happen if I change this one to 13? So let's give it a try. I will do that to 13. I will click enter, and remember, we are currently into the database. I'm clicking enter, and we can see that this value is getting propagated directly to the WebSocket listeners here and here as well. So let's go back to the slides. And that was the last thing that I wanted to show you, just a demo of this small application built with Supabase. And in summary, what we discussed today is about the authentication and the methods, database, and how to create tables, the API, and the real time. And that was all from my side. Thank you very much for your time and attention.
Thank you very much, Fanis, for your insightful presentation. I found it really interesting, and so did our other viewers. So now let's dive into the Q&A session, and let's see what kind of questions do you have. There is already a couple of them, so let me pick this one. Yeah, let's start with this one. So how about if there are more complex queries to retrieve data? Basically, if there is any guarantee, this will work with large data sets with millions of pieces of data.
We can say here that there is a guarantee that we will have a correct response, and the reason is that Supabase, what is using is PostgreSQL, which is the choice for transactional workloads. Since we have PostgreSQL, there is a guarantee to have our data returning back, as soon as we have, of course, the correct query.
Right. Okay, so let me get to the other one, and maybe we can say something more about this, live updating of data, because here we have like a statement that we can achieve this behavior with WebSocket and RxJS subject, yeah. But yeah.
Definitely. We're going to achieve that. We're going to achieve the same behavior, and this is what I was using before I met Supabase. But what I would like to say here is the following. If you're using Supabase as your backend as a system, as a service, then why do you have to create another WebSocket listener? Since you are already there, perhaps it's the best option to use the Realtime that they also supported. I feel that if you have to do something else, what you have to do is to create, of course, a three-tier architecture, have your own database, have your own API, and that API to create a new WebSocket server. I don't think I wouldn't do that, to be honest. At first, I would rely to Supabase.
Right. Okay, so we have another one. So what's the difference between Firestore and Supabase?
This is a very interesting one. So Supabase, like I said previously, is using PostgreSQL, which is relational database, while Firestore is not relational data. And this is one of the differences that I can see. One of the big differences, if you have an application and that application uses relational data, I think that I would go to PostgreSQL and not into the Firestore.
Okay, and we have another similar one, so I will not repeat this one. And there is one more interesting question. Maybe you will know if Supabase is okay for geolocation points.
This is an interesting one. I'm not sure about that. I remember in the past that I worked with PostgreSQL. There is a specific type for geolocation points, but to be honest with you, I don't quite remember how this is happening. And yeah, but this is an interesting one. I will keep a note, and perhaps I will create an article about that of how to achieve that. Thanks for this one, Emilio.
Okay, that's great. And one more. This is probably about some behind the scenes of this, live data sharing. Is that temporary table for two users while playing?
I'm not sure if I quite understand what we mean by temporary table. This is a table that I created using the nice UI that they have, either by create table using the SQL editor. So it's a legit database table. It's not temporary one. And the one that I showed previously, where we had the data, that was actually the Supabase dashboard. That was the Supabase instance that they had into their cloud host. I'm not sure if this answers the question.
I believe so, but yeah, hopefully. And
what's the difference
between...
between...
last one related to the authentication, like what's the difference between Auth0 and single sign-on?
Well, in OAuth, what we can do is that we can select different providers and accommodate this kind of different providers. With single sign-on, there is no requirement to go with using this one. With single sign-on, we can use our own data set from our database without relying on any other provider. This is one of the differences that I'm seeing here.
Okay, so thank you very much, Fanis, for your presentation, for answering all of these questions. And yeah, hopefully we can see each other at the future events in Angular Love or anywhere else. And by that time, take care.
Thank you very much.
Bye.
Thank you all. Bye.